Welcome, in this video we are going to learn tcptraceroute information gathering tool. What's tcptraceroute? tcptraceroute is a traceroute implementation using TCP packets. The more traditional traceroute sends out either UDP or ICMP echo packets with a TTL of 1 and increments the TTL until the destination has been reached. By printing the gateways that generate ICMP time exceeded messages along the way, it is able to determine the path packets are taking to reach the destination. The problem is that with the widespread use of firewalls on the modern internet, many of the packets that traceroute sends out end up being filtered, making it impossible to completely trace the path to the destination. However, in many cases, these firewalls will permit inbound TCP packets to specific ports that hosts sitting behind the firewall are listening for connections on. By sending out TCP SYN packets instead of UDP or ICMP echo packets, tcptraceroute is able to bypass the most common firewall filters. It is worth noting that tcptraceroute never completely establishes a TCP connection with the destination host. If the host is listening for incoming connection, it will respond with an RST indicating that the port is closed. The host instead responds with SYN or ACK, the port is known to be open, and an RST sent by kernel traceroute is running on to tear down the connection without completing three-way handshake. This is the same half-opening scanning technique that Nmap uses when past the -SS flag. How tcptraceroute works? It uses TCP SYN package and set TTL as 1 as initial packet to send to network. Each hop will decrease TTL by 1, so each hop will generate a time exceeded ICMP packet back to the sender. Those ICMP packet includes the original packet information. For the next hop, the sender will use TTL2 until the destination, which will also send back TCP SYN or ACK reply to the sender. -n displays numeric output rather than doing reverse DNS lookup for each hop. By default, reverse lookups are never attempted on RFC 1918 address space, regardless of the -n flag. -N perform reverse DNS lookup for each hop, including RFC 1918 address. -f set initial TTL used in the first outgoing packet. The default is 1. -m set maximum TTL used in outgoing packets. The default is 30. -p use the specified local TCP port in outgoing packets. Default is to obtain a free port from the kernel using bind. Unlike with traditional traceroute, this number will not increase with each hop, and so on. Let's open up terminal, type tcptraceroute. Here you can see that basic syntax tcptraceroute -hv -hvn fcae -i dev -f furst -tt1 -l length. Clear the screen. To trace the path to a web server listening for connections on port 80, type tcptraceroute space hacking2.com. You can see that traceroute to hacking2.com 30 hops max, 60 byte packets by default on the port 80. Let's use traceroute to know network path. Type traceroute space google.com -p443 -f2. Here you can see that trace the path to Google server listening for connection on port 443. Set initial TTL used in the two outgoing packet. Detect transparent proxy in between. Type tcptraceroute google.com -f2. Compare above port 80 output with port 443. We know there is transparent proxy in between. It stops before reaching redhat.com. So that's it in this video on tcptraceroute information gathering tool in Linux. Thank you for watching this video.